All right, guys. So last class we finished up right here. We had already found our bounds on this, right? So all we need to do now is find the actual area in the underneath the curve. So our setup is still f minus g, your top function minus your bottom function. Which one is my top function? Sine. Which one is my bottom function? Cosine. Okay. Could have that been different if we were looking in different places? Yeah, absolutely. So my integral is going to be from pi over 4 to 5 pi over 4 of sine x minus cosine x dx. And from there, y'all should be able to do that integral, right? You should just break it up. When we break it up, what's the integral of sine x? So we're going to have sine goes to negative cosine. And then we got minus. What's the integral of cosine? Sine? No, sine. Sine x such that we're going from pi over 4 to 5 pi over 4. Yes? All right, I'm going to let y'all figure that out. I'm going to come around and snag those purple sheets. Sean, do not. This is the non-calculator part of the AP test. Do not. All right, so she did the fundamental theorem of calculus, which was good, f of b minus f of a. And she just plugged in the 5 pi over 4 and the pi's over 4. When she used the unit circle and distributed this negative, that's the key. You have to make sure you distribute the negative. She got square root of 2 over 2 plus square root of 2 over 2 plus square root of 2 over 2 plus square root of 2 over 2, which is 4 square root of 2 over 2. When you simplify it, it is just square root, just 2 square root 2. Fairly straightforward. Guys, for the AP test, they are not super rigorous on the unit circle. Most of the answers are going to be axes. Your x-axis, know what your x-axes are, know what your y-axes are, and at worst, it's going to be these 4s, the 45s, the square root of 2 over 2. Those are going to be the worst they do to you. Okay, any other questions about this problem? No? All right, let's move on. Another one of these? Or you want to move on to a new concept? Try another? Okay. So I'm going to tell you f of x equals sine of x and g of x equals 1/2. And I'm going to tell you it's bounded, but these are not your bounds. You still have to find your bounds between 0 and pi. So, all right, I'm unmuted. All right, so, dagnabbit. Open alligator clip. Okay, so we're going to get sine x equals 1/2, and I'm only looking for the answers between 0 and pi. This bound is telling me, hey, when I solve this, my answers are only between 0 and pi. If I find anything outside of that range, I can't use it, right? Because there's actually an infinite amount of places where sine can equal 1/2. So we're only using the places between 0 and pi. It's not your bounds of integration. So I need to figure out, where is sine 1/2? Well, I can simply take arcsine and I get x equals arcsine of 1/2. But if this is on the non-calculator part of the unit circle, the non-calculator part of the AP test, you're going to have to know your unit circle. So your unit circle, I'm going to draw out quadrant 1. This is 0 radians. This is pi over 3, pi over 4. This is not pi over 3. This is pi over 6. What am I thinking? And this one's pi over 3, and this is pi over 2. Cannot read my pi over 4. The points are from your hand. So if I fold my pinky down, that's my 0 degrees. So I have 4 fingers above, right? And in my hand, I have the square root of my number of fingers divided by 2. Imagine that in your palm. So if I have 4 fingers right here, what's my x value? I have 4 fingers. What's the square root of 4? What's 2 divided by 2? 2 divided by 2? 1. And then, is there any fingers down here? Below this finger? No, so that's 0. So this point is 1, 0. So now we go to pi over 6. I fold down my ring finger. How many fingers are above my finger? 3. So this becomes square root of 3 over 2. And then I have 1 folded down. That's 1/2. Hey, but sine is my y value. Look at that. There's one of them. So I don't need to keep going on the unit circle. So now I know one of my bounds of integration is going to be pi over 6. If you look at that pink sheet, which is actually going to help you find your other answers on solving a trig equation, there is a thing called a reference angle. Well, pi over 6 is going to be my reference angle because it's in quadrant 1. And it tells you that in quadrant 2, to get your answer when sine is positive, we're looking for quadrant 2, the other place where sine is positive. It is 180 or pi minus my reference angle. Well, my reference angle is pi over 6. So I'm going to do pi minus pi over 6, which is 5 pi over 6. Or if you have the entire unit circle memorized like I had y'all do last year, right? You should be able to remember, hey, you know what? It's pi over 6. We're in quadrant 2. I'm going to take my denominator. I'm going to subtract 1 from it. That's part of my numerator, 5 pi over 6. So look, 6, subtract 1, 5 pi over 6. That's quadrant 2. Or you can memorize these formulas for quadrant 2 and quadrant 3 is pi plus your reference angle. And quadrant 4 is 2 pi minus your reference angle. Right? So now I have my bounds of integration, pi over 6 and 5 pi over 6. Because you guys was walking around, I liked your sketch. Y'all had like this, and then you had something cutting across, and you knew you were finding this, but you needed to know. Well, that's horrible. You needed to know this bound and this bound. You need to know this. A, B. Well, here's your A and B. So this is solving simple trig equations, but you've got to be able to do it off the top of your head. This is part of what makes calculus difficult. In pre-cal, these were super easy problems. You're like, oh, I got this, because the unit circle was fresh in your mind, and you can spit the answers out at me. But it's been a while since you've had to do that. Right? All right. So now that you know your bounds of integration, knock it out. All right, guys. So we finished this problem up. There's only 5 minutes of class left, so we're not going to start another problem. Clearly, you can see these problems take more than 5 minutes. We're not going to leave right now. You get out of 40. Good try.